All right, so we decided we're starting to write our multi-user dungeon, whatever. What do you think? Should we just switch programming languages? Why not, right? I mean, you've spent all this semester so far getting used to C++, so why not just switch right now? So we're going to try to prove a point. If you remember back to the very beginning of the semester, we talked about how human beings solve problems, memory, asking questions, repetition. I said 100% of programming languages have facilities for these things. We looked at the chart of the history of our programming languages. And let me just start sharing am I already sharing my screen? I don't think so. Oh, I am sharing my screen. All right, whatever. So we already talked about history of programming languages. And we saw that we have kind of C, C++ at the top. We've kind of talked about the object-orientedness of C++. More recently, we've looked at C++ in terms of writing classes. So we've started differentiating C from C now that we've been writing classes. They don't exist in C, which is a procedural language. So C++ is an object-oriented language. I did mention that 100% of programming languages have facilities for solving those problems using the tools human beings use to solve problems, memory, asking questions, and repetition. So with that in mind, what we're going to go ahead and do is we're just going to decide to start working on our new project. So let's create new project. We're going to call, and we're going to switch the language here to Java. So we're actually going to be switching languages a couple of different times. We're going to be using Java for the rest of this term as we write this project. And then we're going to, in the next term, in 250, we will start by converting our dungeon crawler, or MUD here, into a Unity game engine, and which uses C#. So we're going to almost immediately convert our Java-based implementation of our dungeon crawler into C#. And hopefully you see how similar all these languages are. And the number of changes we have to make is very small. So hopefully you end up believing that the idea is you learn that programming is the skill set, the language really does not matter. All right. So for the rest of this term, we're now Java programmers. So let's jump into it. All right. So let me get our plan here. So at the end of class last time, we looked at a picture of what a multi-user dungeon thing looks like, kind of a text-based Dungeons and Dragons. And you know, we started thinking about what are the, if we view our game as kind of like a movie scene, what are the actors that we're going to see on stage, right? We're probably going to see some players wandering around. We're going to see some monsters wandering around. Where are they wandering around? They're wandering around in rooms. How are rooms connected to other rooms? Maybe they're connected by exits, something like that. So we might have something like an exit. All right. So let's start off with the idea of, well, let's actually just write our player first. So we're going to create a new file, and we're going to call this guy player.java. So in Java, the name of the class has to be the name of the file as well. Same thing was true in C++. So we're going to create a file called player.java. All right. And this guy is going to be public class player. Like that. You could even just say class player. You didn't even need to say public class if you didn't want to. So if I want to make this look as close to C++ as possible here, we're just going to say class player. So already looking C++-y. All right. So now what makes a player? At the very least, do you think players probably have names? All right. So if we go back to our our planning process here, and we talk about the player class. Does a player have a name? Probably. All right, what else is a player in Dungeons and Dragons going to have? Go ahead. Health, like a number of hit points or something, because when they get into these death matches, somebody's got to die, right? So we can think of them as just losing consciousness. All right, so we're gonna say hit points. All right, let's leave it at that for the moment. We'll add some stuff in. So we're gonna go ahead and we're going to say private string name, private int HP for hit points. So a couple of differentiating things we see already. Instead of having like a public, private, protected section like we have in C++, we just label each thing individually as whether it's private or protected or public. So we have a name that's going to be private. We have a hit points that's going to be private. All right, then we have our constructor. All right, constructor starts looking pretty similar to our C++ constructor. It has the same name as the class name. Takes in parameters just like we had before. Difference still being we label the constructor as public rather than putting the constructor inside of a section called public. All right. We want to set these fields, the field name equal to the name that was passed in. We say this dot name is equal to name. So right off the bat, let's look at a difference here. If we were doing this in C++, we would have said something like that, right? The little arrow guy. So one of the things that has disappeared in Java that existed in C++ is a special syntax for dealing with pointers. So in C++, we would have had to say, okay, well, this guy right here is actually a string pointer, and we're going to set it equal to whatever was passed in here. So we actually have to dereference the pointer. That's when we use the arrow thingamajiggy. In Java, it just figures it out. Java doesn't give us a special format for dealing with things that are pointers or things that are not pointers. Java just says, look, if this is something that should be a memory address thingy, I will make it work. If it's something that shouldn't be a memory address thingy, I'll make it work that way. Right? So in Java, we are setting the string associated with this player so that his field name equal to the name that was passed in. Similarly, we'll say this dot HP is equal to HP. So imagine it's probably just going to take a little getting used to start to drop the arrow out of your problem solving and just start using dots for everything. All right. So that's what our player initially looks like. And we're going to go ahead and we're going to give the ability for a player to maybe display itself. All right. So in C++, we would use cout, right? To output something to the screen. In Java, system.out.println. And we can actually walk this in terms of, we talked about a hierarchy in C++. There exists a class called system that has in it a field called out, which has in it a function. This is out is a variable of type print stream, which has in it a function called println. All right, so we're going to go ahead and print out, hi, my name is something like this dot name. So string concatenation works the same as it did in C++. All right, so let's leave it like this for right now. Okay, so small little changes, but largely this doesn't look all that foreign to us. You know, we're gonna, in fact, actually, some of the probably the worst part of Java, especially since it's something you start using right from the get-go, is system.out.println. Like, why didn't they just like make it that? Or just print? The print, there is a print. There's a system.out.print and there's a system.out.println. Println presses enter at the end of the line. So you don't have to do your /n or your endel thing. Print doesn't. All right. You would have thought as often as you might print stuff to the screen, why make you give it this full-on thing here? And if you just kind of want to see this real quick, I'm going to say Java system, just so we can look at the documentation and kind of see what's actually happening there. So here's the class called system. Notice that system is an object. So it gets everything that generic objects have, and then it adds some stuff to that. And notice it has a field. So here's the list of fields. Remember, all objects are made up of fields, constructors, and methods. So here's the list of fields. One of the fields here is called out. So that's a variable. That's why we don't have parentheses on it. It's system.out dot something else. So out is a variable of type print stream, whatever that is, but it's another object. How do we know? Well, it's got a capital P at the beginning of it. So typically things that have capital, that use capital as the starting letter is probably a class, just by naming convention. So if I happen to click on print stream, we can scroll down here. We can see the method summaries, and we can see there's a whole bunch of methods in here. There's a method that knows how to print a Boolean, knows how to print a char, knows how to print a char array, a double, a float, an int, a long, blah, 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 string, generic objects. We'll talk more about what's the difference between a string and an object in this later. Then you see these printfs. That's actually from a C++ library. Before there was cout, there was a C library called printf, which was a formatted print statement where you could give it a format. So that's carried on actually from the C days into here. But here's all of our different methods here called printlns, and all of those know how to print out all our primitive types plus strings, and they press enter automatically at the end of the line. That's it. All right. So frankly, that's probably the most annoying part of Java, is that their to print something seems way more convoluted than it should. It's very long-winded to print something. But in any case, this is how we print stuff. All right, let me hide this so it's less in my way. Okay, so now let's go ahead and try this player. Let's use this player. So this is no different than what we did in C++. In general, but notice we no longer have a header file. Now, one of the reasons I talked about header files being handy is you can look at them at a glance and kind of see what the ability is of this object, right? And then you can go and dive into the actual implementation of it in another file. Not the end of the world, but in this particular case, Java doesn't allow for header files. Instead, everything lives in the same class. I did mention why in class someday when I got off on one of my, anybody remember why Java doesn't have header files? When Java first came out, it has a technology built into it called JavaDoc. And they imagined that all the developers would just put little, JavaDoc has like little syntax like this, where you put @ symbols before stuff and you give it little keywords, and you basically would write your documentation into your code using this JavaDoc syntax. And then at the end, you could run JavaDoc and it would turn all your classes into formats that look like this, giving you documentation, your own header file that you can glance at and see, in this case, what's all the stuff print streams can do. So whoever wrote the print stream class at Sun Microsystems, who made Java and then Oracle bought them, would have put a bunch of JavaDoc stuff in there. And then at the end, they ran the JavaDoc tool, which generated this HTML page in this format. So all Java documentation looks like this. So they imagined that programmers were going to all do this. We didn't. Okay, because programmers tend to be a lazy bunch. We don't type in a whole lot of extra stuff if we don't have to. So what we gave up was the idea of kind of a header file, which is, almost like the Cliff Notes for, is Cliff Notes still a thing? Still exists? Is it Cliff or Cliff's Notes? Like a short version of a book. So a header file is kind of like a little short summary of what a thing can do. We don't really have that in Java because of the nature of it. We do sometimes rely on the fact that, I don't know if I maybe have shown this before, but if you notice over here to the left on online GDB and most IDEs, development environment text editors made for software development, a lot of them have these little arrows where you can minimize your functions and stuff. So effectively what I'm looking at there is a header file. Sort of, kind of, right? All right, so you can decide if you like one or the other one better, but you're stuck with Java that they don't use header files. So you have fewer files to keep track of, but you get a little bit more of a wiry look in your code since all the implementation and definition is all in one place. All right, so let's go and build an instance of our player. When we build a player, the constructor says we have to give it a name. We have to give it a number of hit points. So I'll come out here. Remember, all programs begin and end with main. Now, in online GDB, they name the main class. They happen to call it main. It doesn't actually have to be called this, but I don't think there's a way for us to rename this file. If I remember correctly. Does it let us change this one? Oh, it does. Well, the default one it gave us was mud. I'm going to rename this. You don't have to, but just so I can kind of put another point out there. I like to call my file that has main in it, I like to call it driver. Now, the name of the class that goes must be the same as the file name. So I'm going to call this guy driver. Now, if you wanted to leave it as main, that's fine. I think it's a little bit confusing maybe if you have a capital M for main for the class name, and then you also have this method called main that's after it. But the reason I like driver for the name of our program that has main in it, the file that has main in it, is it's compatible with software that many of you probably have dealt with before. Have any of you ever installed a piece of hardware or something like that and then had to install the drivers for that hardware, right? Like a graphics card or something like that. That's the piece of software that runs that hardware, right? So this would be the piece of software that drives our program, the driver for our program, all right? So I tend to like naming it, but it doesn't need to be called that. All programs begin and end with main. So we have our main method here. Remember, in C++, this would have said void main. We got away with just leaving it like that. If you went a little old school with this, it would have been void main int argc char pointer argv. Leave it like that. If you don't like that syntax, this one will probably feel a little bit better. So these two things really do the same thing. In Java, we're taking in an array of strings. That's what the main method takes in. In main, for C++, we also took in an array of strings. This is to allow us to do command line arguments, which we'll probably rarely do, but we could. And I'll even show you an example of it here in a few minutes. Actually, will we be able to do it very easily here? I don't want to screw with it. Do I? Maybe. I can give it a command line argument. let's not screw with it. All right, so this is taking in an array of strings. That's what a char pointer is, right? Char pointer effectively is a string. It's the beginning of an array of chars. And if I have a collection of char arrays, I effectively have a collection of strings. Now in C, well, C++, why do I have this separate variable here? We talked about it in class, but I'm just connecting some dots now with another program. What does argc stand for? We didn't have to call it argc. We could have called it LOL if we wanted to, but usually we want to have variable names that have meaning. So what do you think the meaning of argc is? What does it stand for? And it's related to arrays in C++. Go ahead. Okay, what about it? Okay, because arrays can't report their own size, right? C++, arrays don't know how big they are. Java, they do. Okay, so in C++, we had to send in the argument count, the number of arguments that were passed to this program when you first ran it, and you had to pass in the actual collection of arguments. All right. We can do that as a single parameter in Java because arrays know their length. Let me actually just show this. I'll comment out this line. Notice it's the same syntax for comments in Java. I already have hello world here. I'm going to do a system.out.println. And I'm going to say args.length. All right. And then I'm going to, before I run this here, I'm going to come down and I'm going to give it some command line arguments. So online GDB lets me type them into this little box. And then when it runs my program, it passes them in. The old school way would be when I ran this program from like DOS or the command line terminal in Unix or something, I would say Java space driver, and then I would give it my command line arguments like cat and dog, something like that. All right. And what am I printing out? I'm printing out the length of args. That is, how many elements are in this array? And there's my 2. If I want to actually see that, I can say int I is equal to 0, I is less than args dot length, I plus plus. Oh, I'll leave that up there. All right. So all programs begin and end with main. What does main say to do? Print out hello world, then print out the number of command line arguments that we received, which will be args.length. Then write a for loop. This for loop should look pretty similar. Basically C++ syntax, except arrays are upgraded now. An array can say how long it is. So I can ask args, how many elements are in you? And each time through, I'm going to print out whatever string was that bucket I in args. Same syntax for working with arrays. And since I am, does it let me keep my cat and dog thing? Or have I lost that forever now? Yeah, it did. So notice here, now 2 command line arguments, and it printed out cat and dog. So if you were writing a program that you did want to be able to give some initial inputs to when you were first launching the program, that's when you would use command line arguments. Super, super, super popular back in the days when people were running programs from the command line because we didn't have graphical user interfaces. Not so popular today. Although if you've ever gotten a little bit, for some of you who are gamers maybe, and you have some kind of weird setup on your system, maybe you've had to debug before where you change, you could right click on the icon for a program, you can change any command line arguments you want to be passed to it when Windows launches it for you. It still exists, just it's not very, they don't throw it in front of you very much anymore. All right. So really, this isn't something I'm going to test you on, but it's something I want you to appreciate, that that's what all this crap is. It's because these languages came from older languages, which very much supported command line arguments, because that was the way you launched your program before. If you wanted to edit a file, today we open up Microsoft Word or something and go file open, right? Well, back in the day, if we would use a command line editor like VI, we would have to say VI space my document.txt. We had to tell it the file that we wanted it to open, that we wanted to edit. There was no file menu. It was all done from the keyboard. A mouse didn't even exist. Okay. So you don't really have to worry about this really for your programming experience, with the exception that in Java, it makes you write this. You don't have to call it args. You can call it elephant if you want, but you do have to take in a string array as a parameter, even if you're not going to use it. Whereas we got pretty comfortable in our programs just omitting that stuff, and it didn't really complain. All right. So there's your example of maybe using command line arguments if you wanted to. I'm just going to go ahead and dump those. It is interesting though. Do I have a way of like removing them, or just, oh, actually, I bet you, can I just, there we go. All right. What's up? I just pressed enter. That's what it told me to do. It's always the last thing we do is read. Even though that's what I harp on you about when you're learning to debug your code. And most of you are probably, or at least many of you, I'm guessing, are still victims of this, where you get an error, so you just see the red stuff and you don't actually read what it says. You just go back and start changing things. It's usually worth at least reading it once. It might give you a less than friendly error message that doesn't give you a whole lot of information, but it's worth looking at, because let's call it 80% of the time it should give you something useful, or at least tell you the line of code that it ran into when things zigged when they should have zagged. All right, so here's my main method. I'm going to go ahead and I'm going to create an instance of our player. So player P is equal to new player. What did player need in order to construct one? It needs a name and it needs a number of hit points. So give it my name, some number of hit points. And then we'll say p.display. There's my, hi, my name is Mike. Pretty much identical to what we had in C++ for creating an instance of an object, with two things missing. One, notice that we did not have to come to the top of this file and do something like include player.java or player.hpp, that kind of thing. It knew about this because it knows to look inside the same directory you're in. That's called, in Java, it's called the package. So we didn't need to include that. It knew to look in our own stuff. And then once again, we saw we did not create a player pointer called P, which then would have required us to put this little arrow thing here. Again, Java doesn't have a syntax for pointers. Java just says, oh, okay, you're going to create a player named P, no problem. We're going to go ahead and treat that as an object for you. So we can say p.display. All right, we saw this run, but I am going to prove to you, so something a lot of Java textbooks use, say, which is why I don't like using textbooks for any programming class. They get outdated, and I don't know, I just like the way I say it better. But a lot of Java textbooks lie to you. They say, oh, pointers don't exist in Java. Well, remind me, what's a pointer? Somebody on an exam were to ask you tell me everything you know about pointers, what would you say? kind of value would a pointer hold? Go ahead. Address, memory address. All right, so we'll just go ahead and print out the value of P. And here's our funky looking memory address. Right there. Pointers exist. We just didn't get to choose whether it was a pointer or not. Java made that decision for us. Java also runs inside something called a virtual machine. So your program actually is housed inside of a little pod, separated from the operating system, so you can't do too much damage. So notice that it actually has its own little kind of format for memory addresses because it maps it to a real address under the hood. Unimportant for us. You notice this is a hexadecimal address after that. So these are pointers. All right. But we didn't have to specify that. We don't have the syntax to specify that. In Java, it just says, oh, you're making an object, no problem. We're going to go ahead and, well, first of all, we should have known pretty quickly when we saw the new keyword sitting there. You know, we're already familiar with that dude. New keywords basically are a real estate agent, goes and finds us some memory for some stuff. We're proving there's the memory it found. All right, questions about that? All right, so far, minor little changes, but largely we're looking at something that we've seen. All right, so now let's think about monsters. So monsters would be the computer-controlled things that we're going to be, you know, going around and fighting in our dungeon, right? Do monsters have names? Probably. Yeah. You know, at the very least, it might be just the orc or something like that, right? If I'm going to be fighting with them, do monsters have hit points? So really, players and monsters have both of those things. Correct? Now, do you think that we're probably going to end up being able to further differentiate players and monsters from each other? At the very least, when it comes to like movement and things like that, the player is probably going to say go north or whatever with the keyboard, where the monster is maybe going to be making some decisions on its own, whatever, however we end up writing that. But so we imagine at some level they do differentiate themselves, right? But at the very least, right off the bat, players and monsters have some commonality, right? And this is where inheritance comes in. All right. Inheritance, just like the word means in real life, you have a parent and you get some of your traits from your parent. Okay. So object-oriented mechanism where a class can be created to serve as the parent for subclasses, allowing shared attributes to only be written, let's call it once or something like that. One of our goals in programming is when you can help it, don't duplicate code. Sometimes if it's just a quick for loop, it's just easier just to write the stupid for loop as opposed to going and writing a function that you then are going to call from two places, right? But as a general rule, if you have a wall of code here and you don't want to have to rewrite that code over here, because if you decide I'm going to make a little change, you have to then go and change it in both places. Where it would have been better off just to put it in a function, change it in that function, and then call it here. We're effectively going to do that through inheritance. So what I'm going to do is I'm going to come back here and we're going to create a, well, let's do it in our documentation first. We're going to create something called an inhabitant. This is a thing that inhabits our dungeon, right? Types of inhabitants are going to be players and monsters, at least initially. All right. So we're going to call this guy the parent class of players and monsters. So we're going to come into our code here. We're going to go ahead and create another file. This is going to be inhabitant.java. And this is going to be public class inhabitant. And I am really going to basically steal a huge swath of the stuff from in here. So really, we've just gone and redefined inhabitant here to be what player used to be. Again, the class name has to be named the same as the file name. So inhabitant here, inhabitant.java here. It is case sensitive. Constructor has to be the same name as the class, yada, yada, yada. So we've decided that all inhabitants of our dungeon will have a name and have hit points. Make some sense? So then what we'll say is for a player, we'll say a player extends inhabitant. That means a player becomes an inhabitant. It's taking inhabitant as its base. And then we're going to extend that class to be more. Similarly, I'm going to go ahead and create a monster. And monster is going to look a lot like player. So we're going to have a class monster. And we're going to say that this guy extends inhabitant. All right, so now out here in main, we can create a player P, we can create a monster M is equal to new monster. I don't know, what is this guy? Rat, he's a rat. And rats are pretty weak, so we'll say they have 4 hit points in this case. Then we'll say P display yourself, and we'll say M display yourself. All right, so right off the bat, we start getting errors. It says constructor player in class player cannot be applied to a string and a integer. Well, that's what we decided all inhabitants have. But I'm building a player here. I didn't even write a constructor inside of player. I think I mentioned this last class that if you're writing a class and you don't write your own constructor, one will be provided for you that does nothing. So if I wanted this error to go away, it's not the way we're going to end up handling this, is I can do that. Because there is a constructor in player that does nothing. There is a constructor in monster that does nothing. So now notice that inhabitant is complaining that inhabitant doesn't have a constructor of the given type. And let me show you what's happening. So inside of, well, either monster or player, doesn't matter. Inside of player here, I told you if you don't write a constructor, a invisible one will be created for you. Okay, I'm going to go ahead and what do we use? Like, how do you get the invisible ink to show up? Isn't there like a water or something or UV? Okay, so we're going to reveal what the invisible ink actually is doing. Okay, if you're happy with the way it's working and you don't need to do any initialization or anything like that, you don't have to write a constructor. But I would say it's going to be pretty rare that you would just not write a constructor. So we would come in here and we would say player. So I'm showing you what automatically was provided to you. That is what was automatically provided to you. A constructor, notice same name as the class name. So the constructor for player here that takes no parameters, and all it does is call the parent constructor. So just as this is how an object refers to itself or within itself, super is how an object refers to its parent from within itself. We have this hierarchy thing, and everything I'm saying now is true in C++ and Java. This is not a Java specific thing. We've effectively created this type of situation. We have this top level thing called inhabitant. We have a player. We have a monster. We've created that kind of hierarchy. And if you really, really, really want to dig a little deeper, above this is a class we didn't even write called object. Put that guy in yellow or something. So in Java, just as there is in C++, there exists a top level object named object that all classes extend. So if we were to go back and look at our code here, and I would do that UV light thingy again, what actually we see here in inhabitant is that. An inhabitant extends the generic class object. That's just part of Java. But if every single class you ever write will inherit from object at some level, isn't it reasonable to say you don't have to write that? Sure. But this is the reason why I use a language like C++ initially, because I want you to see some of those details before Java starts hiding them from you. Make some sense? All right, so an inhabitant, since it doesn't extend any of the other classes that we've written, by default will extend the top level object class. And we already saw that in here when we went to look at print stream. So notice here that a print stream extends filter output stream, which extends an output stream, which extends object. So object is the most generic object type that exists in Java. C++ has one of those too. His name is object. C# has one of those too. His name is object, but with a lowercase o for no reason. C# also uses a lowercase s for strings instead of an uppercase s. Actually, strings were lowercase s in C++ too, right? So those are the stupid little differences you're going to run into when you're bouncing between programming languages. Capitalization, system.out.println instead of cout, or instead of printf, or if you're a Python programmer instead of print. You know, these little nuances that really have very little to do with the structure of the code, right? We're still going to write for loops. We're still going to write if statements. All those things still exist. All right. So back to our player here. So that guy, you can leave that in there. It's not an error. You can say inhabitant extends object, but it is put in there for you in the invisible ink. All right. So we go back to player here. So what I'm telling you is if you don't write a constructor, if you don't write anything in there in player, what magically gets written for you is that. Which allows this syntax here at the very least to work, which means that you can always at least attempt to create an instance of your object. We still have an issue here. I'm going to explain why. But that's why that syntax exists. The new keyword is always, 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 always followed by a constructor. So if you didn't write one, it's going to call the no argument one that it magically put there for you so that this syntax works. That makes sense? But the kicker to that is, if you did write a constructor like we have here, it will not give you an invisible second constructor that takes no parameters. It won't invisibly give you that guy. Because you chose to write it, Java is going to assume, oh, you know what you're doing. I'm not going to go in and give you that default syntax because you've taken control and said you're going to take care of it. Make sense? Now, who is inhabitant's parent? Object, right? So in that case, we'd be calling objects constructor, which, by the way, does have a no argument constructor, because when they wrote object, they said, well, there's nothing for us to initialize, as this is an object exists just to be the top level. We got to inherit from something at some level. So we don't get this guy since we chose to write our own. And what does that mean? It means that for inhabitant, the constructor takes a string and an int. Inside a player, since we didn't write a constructor, and I told you this magical text gets written for you in invisible ink, it's trying to call the parent's constructor. The parent is inhabitant, passing it no parameters, when the parent here takes 2 parameters. Make some sense? Now, you can muck around with this and get it fixed. Sort of. You can say, okay, well, I'll go ahead and write the no argument constructor because, well, I'm not sure what to do here. And maybe I just hard code some stuff in here like that. And let me come out to driver. Let's just get rid of the monster part for right now. We'll just look at players. So now inside the player constructor, I'm going to go ahead and write the no argument constructor. Because if I don't write it, Java is going to take complete control and write the one that takes no parameters and calls a no parameter parent constructor. And I don't have one of those. So I'm going to go ahead and write a player constructor that for some reason I took no parameters for. We're going to be fixing that. But I'm going to go ahead and make this work by going ahead and calling my parent's constructor, passing it a string and an int, which is what he's expecting from me. What year is it? Yeah. Let's give that another college try. It is so weird that it does this. We're going to use Unity. Yep. Where's my projects? Shouldn't my projects be popping up? Or is the site just down? Oh, the site's down. Great. Is the internet down or just the site down? You got internet? Yeah, internet's up. Okay, that's fine. So let me let's just create a new text file here. Let me create a directory. Downloads. New folder. That guy. All right. We can copy stuff back over once it goes live again. Just test this thing real quick. See if it's back up before I. Nope. And it's down for everybody else. Nobody else can reach it. Okay, that's fine. Aha! It's back up now. My projects. Well, anyways, I was going to run it locally on the computer, so which would have worked just fine. All right. So in any case, we have our player. It kept everything I had, so we're good. I'll go ahead and run this again. Oh, it's complaining about my monster. Let me just appease it. Even though I wasn't using the constructor for monster, it was trying to call the thing behind the scenes. All right. So it's all happy now. We're not quite having it work the way we want it to work yet, but now I was able to create an instance of player using a no argument constructor. Why? Well, I decided to write this no argument constructor because maybe I'm confused, but internally I was calling my parent's constructor for my parent to start doing some initial setup. And then I passed, and my parent takes in a string and an int. So I had to pass it those two things. If I don't write this in here, and I write that no argument constructor and I hit play, notice it's upset again. Why? Since I didn't make a call to my parent's constructor, it's going to try to make one for me. Why is that? Because it is creating this hierarchy. When I create player, a player extends inhabitant. So therefore, in the constructor for player, if you don't call your parent's constructor, it will call it for you, assuming there are no parameters. Yet when I look at inhabitant, there are parameters. The only constructor that exists for inhabitant takes a string and takes an int. True for C++, true for Java. All right. So realistically, inside of player, we would have the player constructor take in a name and a hit points. And then we would go ahead, and since our parent already knows how to get this guy set up with name and hit points, I would go ahead and just pass name and hit points to my parent. So far, so good. We would do the same thing inside of monster. So monster's constructor would also take in a name and a hit points, but rather than locally do anything with it, it would go ahead and pass it off to its parent. Why? Because the parent already has a constructor that knows how to take in a name and hit points and set it to the right stuff. So let's not duplicate code. I would say nothing kept us from doing something like this. Oh, still writing C++. Nothing kept us from doing that, almost. Except if you go back and look at inhabitant, name and hit points are both private. And what does private mean? Can only be accessed inside of the class called inhabitant. If I'm in monster here, am I inside the class called inhabitant? I'm inside of a class that extends inhabitant, but this class is not inhabitant itself. So if I want to have access to those variables, the fields of my parent, well, here, let me show you the error you'll get first. So I'll leave that in there for right now. And I'll pass this guy. Mike gets 15 because we rewrote that constructor. Player takes those two things, calls the parent with it. Monster takes those two things. We're not actually calling it yet, but it sets the name and the hit points equal to something. It still calls the parents thing. Let me just do that. When you call the parents constructor, it has to be the very first thing in the method or in the constructor. So what you do is you call your parents constructor first to do some work, then you make changes as needed after that. All right, so here it says name has private access and inhabitant, which means we only have access to that variable if we are inside of a class called inhabitant. I'm trying to access it from inside of a class called monster. Not allowed. Even though monster is a inhabitant, it extends inhabitant, so a monster is an inhabitant, just like all of us in here are humans. And then we have further differentiated ourselves from the idea of a generic human, right? So even though we are an inhabitant in here, we are not in a file called inhabitant. Therefore, we would not have access to the private fields or private methods of that guy. But if I want to give myself access to this, I would change the security to a third one that I think I probably mentioned it before, but we haven't talked about it because it's inheritance based. We have public, private, and we have protected. Protected means we have access it inside of this class as well as children of this class. Okay. So now by loosening the reins on those guys, you've heard me say that thing, like make everything private first and then loosen it a little bit if you need to. In this case, I very well might want to have access to the name and the hit points of these things, not for the construction part of it, but we imagine that we might write some other methods that the name might be handy, something like that. So if I want to have access to those inside of children and inhabitant, I need to change the protections to protected, the security to protected. And then inside of monster, I would be able to do this. Okay, so it's all happy again from a syntax perspective. I've put a couple of lines in there that don't make much sense because we're constructors doing that heavy lifting for us, but we'll deal with that here in a minute. All right, so questions about the idea of protected. Protected is a keyword that, similar to private, allows members to be accessed within the current class, but adds the ability for them to also be accessed in children of the current class. All right. Now, the reality is, now that we've kind of covered the academic aspects of that, where I had to force the code into different error states in order to explain the things, when we build a monster, we've decided that all monsters have names and hit points, and we've decided that all players have name and hit points. So we've written this top level inhabitant and said, all right, you're in charge of maintaining, at least at this point, the similarities between players and monsters. So you're going to control the name and the hit points. And we already wrote a constructor that knows how to set those things. So we'll go ahead and just have monster call upon the parent's constructor. And we'll have player call upon the parent's constructor. And inhabitant will actually do the work. Make some sense? All right. So the reality is at this exact moment, players and monsters are they're basically identical to inhabitants, other than we call them players and monsters. They have nothing special, nothing that differentiates them from inhabitants other than just the name of the class. All right, so here's our display method. Now, what we're going to do is we're going to decide, you know what? We want monsters to have their own display method. Maybe monsters, I don't know, growl, grr, whatever. That's what Monster Dave here does. All right. So notice here inside of inhabitant, we have I forgot the void here. Notice here inside of inhabitant, we have written a method called display that prints out, hi, my name is whatever the name was. Now, monster, we've gone ahead and we've also written a method with the same return type, same spelling. We've written a method called display, and this guy prints out grr. All right. So now when we run this out here, we're creating a player, we're creating a monster, we're telling the player to display himself, whatever that means. We're telling the monster to display himself, whatever that means. And we're going to see that we get different behaviors. So our player said, my name is Mike, just like before, but a monster says grr. Okay. This is effectively the same thing as we discussed with scoping rules. Just as variables resolve to their most local definition, so do methods. So in this case, when we say m.display, we are asking monster to call his display method. Specifically, we're asking him to call his non-static display method, right? That whole lesson we've been talking about with static versus non-static, same thing in Java. Nothing different about it. All right, we haven't written any static stuff yet, except main is static. Main only exists one time in our program, hence it being static. All right, so we created our monster. We told our monster to call his display method. Actually, let's do player first. We told our player to call his display method. We go into player, we look around. Do we see a display method in here? Nope. But do we have other places we can look? Yep. Let's ask our parent, like, hey, do you have a display method? We look in the parent. Parent does have a display method, so it's this one that gets called. If parent didn't have a display method, are we done looking, or do we still have another place to look? We just pass the buck to object. And if object doesn't have what you're asking for, then it screams at you and says, I don't know what you're talking about. All right, I checked locally, I checked my parent, I checked object. You wrote bad code. All right. So in this case, we looked for it inside of player, didn't find it, then passed the buck up to our parent inhabitant where we did find it, and that's why it called this one. That's why for player, we got, hi, my name is Mike. But for monster, we looked internally in monster first, and we saw, oh, there is a display method. We're going to call this one. We're not going to have to look any further. We already found it. That's why we got the grr. All right. Now, if we still want to have our parents' behavior, I could go ahead and say super.display. I can do it before or after the system now here. Just depends if we want to have the name first followed by the grr, or the grr first followed by the name. All right, so there's the player, and then here's the monster, the 2 lines from the monster. So you could still have a more local definition of a function, like display here, but still leverage aspects of the parents if you wanted to. If you were just adding to the behavior of the parent, you know, like monsters might growl before announcing their name. That's what we've done in this case. All right. But in any of these cases, this guy is said to override or overload the more global method. We've given ourselves a more local definition of this method. And just like variables, methods resolve to their most local definition. So monster's most local version of display is this one right here. All right, make some sense? All right. Now, if we wanted them to kind of announce themselves a little bit, we could have said something like maybe monsters growl first, then called the parent, and maybe players. Ooh, sorry. Let me steal the whole thing. So maybe a player, I don't know. Let's just say I'm a player. For no other reason, a player is going to do that and then still have the parent do the rest of the work. You could decide what makes the most sense for what you're trying to accomplish. All right, make some sense? Realistically, I would say it's not super common that you call upon a parent's method after you've overridden it. Usually you've overridden it for a reason, and it's because the display in this case might mean something very different for the object. But the point is that the super keyword allows us to talk to our parent. When we are inside of a constructor, parents constructor must be first call. If you want to call upon your parent's constructor, it has to be the very first line in your constructor for the child. The rule is that a child initially instantiates itself in terms of its parent, and then it differentiates itself. So we could always do something like this dot HP is equal to this dot HP times 2 or something like that. So we'll let our parent go ahead and set our hit points initially, and then we decide that all players have double hit points, for example. All right, questions on that? All right. So now let's talk about, I mentioned here that we have, where's our, oh, we were designing this. Oh man, I put some of that stuff way up there, didn't I? Just putting it all over the place. All right. Here we go. So when we were starting to design our mud here, we decided that, oh, one of the things we're going to have are rooms. And rooms are going to have exits. So let's define what a room is. All right. So a room is probably going to have a name. What else might a room have? Maybe a description. And a room then also has a array of exits. If we're in this room right now, we have 2 exits here, right? That exit leads to another room. We're going to pretend in our dungeon all the rooms are the same shape right now. So the hallway, that's a room. Then inside there, that's a room. So this particular room has 2 exits in it. And maybe a room has a display method that displays the direction. Well, that displays the details of this room and the directions of the various exits. Now, what is an exit? It really depends on how you implement exit. We can pretend like every room has a one-way door, where the door that's in this room leads, I don't know, let's assume I'm pointing north here, heads to the east out of this room to whatever room is out there. And we have another door that heads to the north to whatever room's out there. Similarly, if we were out in the hallway, there would be a door to the west that leads to this room. That makes sense? Or you could implement exits to be 2-way. So in the example I just gave, we have 2 physical exits. That door will exist 2 different times. Once from the perspective of this room where we head east out of it to the other room, once from the perspective of the hallway where we head west through it into this room. All right, that's probably the easiest way of implementing it. So let's go that route. So we're going to say exit. If you want to do it the other way, though, it's fine. So we're going to say exit has a direction that it leads, and it has a room that it leads to. Make some sense? Homework. Save this. Given this guy, implement room and exit as discussed in class. Then build your own dungeon with at least 5 rooms, and each room should have at least 1 exit leading to another room. Display the details of your dungeon to the screen, say in a reasonable way. So maybe if we have the 3 rooms set up here, and this is our starting room, I say starting room, description is a classroom. There is an exit to the north leading, to, then we call that room and tell that room to say, I'm a storage closet or whatever. And there's an exit to the east leading to the hallway. Something along those lines. All right. So we're kind of building our initial objects and giving you a little practice working with them. We're using Java for this. Submit the self-assessment and a link to your code. All right, questions, comments, concerns, bribes. I'll go ahead and put a little, the very end of the recording here, I'll put the 2 slides there. There's also saved online so you can see it. All right, I will see everybody on Tuesday.